So let's do the second long division problem, and we're asked to find the remainder. Actually, that's all we're asked to do is what is the remainder. So I'm thinking, oh, I can use the remainder theorem. However, I can't because I'm dividing by x squared minus 3. You can only use the remainder when you divide by like x minus 3 or x plus 3. It can't be x squared. I'm going to need to actually do the long division of x to the 8th. I'm going to have to put a lot of placeholders in here. X to the 0, x to the 7th, 0, x to the 6th, 0, x to the 5th, 0, x to the 4th, 0, x to the 3rd, 0, x squared, 0x plus 12, divided by x squared plus 0x minus 3. So, I put all my placeholders in, focus on the first. X to the 8th divided by x squared is x to the 6th. Now I'm going to multiply this. X to the 8th plus 0x to the 7th minus 3x to the 6th. I'm going to subtract, so I change my signs. And since I changed my signs, I can add. I get 3x to the 6th. I'm actually going to need to carry 2 down since both of these canceled out, because since this has 3, I need 3 here. Focus on the first. 3x to the 6th divided by x squared is 3x to the 4th. So I get 3x to the 6th plus 0x to the 5th minus 9x. Oh, this was x to the 4th. Sorry, I didn't mean to carry that down. Carry it on. I'm going to subtract, so I change my signs. And since I changed my signs, I can simply add. And once again, I'm going to need to carry 2 down. And now I focus on the first. 9x to the 4th divided by x squared is 9x squared. When I multiply 9x squared by each one of these, I get 9x to the 4th plus 0x to the 3rd minus 27x squared. Going to subtract, so I change my signs. And get 27x squared, and then carry down the 0x and the plus 12, and focus on the first. 27x squared divided by x squared is 27. 27x squared plus 0x minus 27 times 3. I get 81. Subtract, so I change my signs, and I get a remainder of 90. Alright, so what is the remainder? The remainder is 90.